This illustration shows the entire mechanical architecture of a permanent seal bore packer, PSBP, as it would appear after installation in the well. A PSBP is a high-load, permanent isolation device that creates a long-term barrier between reservoir zones or between the reservoir and the wellbore. The packer body is anchored to the casing using carbide slips, which penetrate and grip the casing to resist axial forces from both pressure directions. The primary sealing comes from bonded elastomer or metal-to-metal seal elements that are permanently compressed against the casing. Above the packer sits the Polished Bore Receptacle, PBR, the unique feature that distinguishes PSBPs from ordinary permanent packers. The PBR provides a precision-machined, polished internal surface designed to accept various seal assemblies from the upper completion, providing reliable isolation even after multiple workovers or tubing pulls. This assembly forms a high-integrity primary barrier, commonly used in high-temperature, high-pressure wells, smart wells, and ESP completions. This illustration zooms into the most critical component, the Polished Bore Receptacle, PBR. The PBR is a long, highly polished, chrome-like cylinder with a mirror-smooth internal surface. This surface allows dynamic sealing with minimal friction and zero damage to elastomers or metal seals. The PBR landing profile inside the bore ensures that the seal assembly can be precisely positioned and anchored at the correct depth. The close-up visual shows how the seal assembly, often consisting of multiple elastomeric or metal seals, interfaces perfectly with the polished bore, forming a robust, interchangeable seal. This allows multiple upper completions to be run and retrieved without milling the packer. Flow paths shown by arrows illustrate that once the seals are landed, all flow must pass through the intended tubing string, ensuring reliable zonal isolation. This capability is crucial in ESP, geothermal, dual string, and smart well systems where high reliability and repeatability are required. This step sequence illustration visualizes how the seal assembly is run, engaged, and landed into the PBR. In Panel 1, the seal assembly is lowered along with the production tubing. The assembly is aligned precisely with the PBR below. Centralizers may be used in practice to avoid damage during RH. In Panel 2, the seals first contact the polished bore. This is a critical moment. The polished bore minimizes friction and prevents seal shearing. The elastomeric or metal seals compress uniformly as the string is lowered further. In Panel 3, the seal assembly is fully landed and seated in the PBR. If a latch system is used, it engages here to prevent unintentional uplift. At this point, the well now has a fully established primary tubing barrier, and flow is directed through the tubing only. This process is vital in workovers. The ability to remove and reinstall the upper completion without disturbing the permanent packer reduces rig time, reduces risk, and preserves well integrity. This horizontal application layout demonstrates 4 real-world scenarios where PSBPs are essential. 1. ESP completion. In electrical submersible pump systems, the PSBP provides a high-strength anchor point below the pump assembly. The PBR allows the ESP tubing to be pulled for maintenance while leaving the permanent packer untouched, preserving well integrity. 2. Smart well completion. Modern smart wells use remote-operated valves, sensors, and monitoring systems across multiple zones. The PSBP creates reliable zonal isolation, and the polished bore allows multiple reentry operations without damaging the packer. 3. High-rate gas wells. High-pressure gas wells require extremely reliable barriers. The PSBP provides metal-to-metal sealing and high differential pressure resistance. The PBR interface guarantees a long-term seal even under extreme cycling. 4. Dual-string tieback systems. In dual-string operations, 2 independent flow conduits must maintain separate barriers. The PSBP can be configured with dual bores, ensuring no cross-flow between zones. This is critical in injectors, SAGD wells, and multi-zone producers.